Sir Isaac Newton was a scientist who lived from 1642 to 1727. He developed the three basic laws of motion and published them in 1687 in a 3-volume work called the Principia Mathematica. Newton's discoveries helped start a scientific revolution and led to the fundamental understanding of how bodies move through physical space. The first law of motion, the law of inertia. Objects will remain at rest or in a uniform motion in a straight line unless acted upon by an unbalanced force. Here we have 3 spheres on a table in a state of rest. The gravity pulling the spheres down is countered by the force of the tabletop pushing the spheres up in the exact opposite direction. The balance of forces is what keeps the spheres at rest on the table. This sphere will act as an unbalanced external force. Without another force to counter its movement in the opposite direction, it becomes an unbalanced force acting on the other spheres. The external force collides with the spheres and changes their motion state. The natural tendency of an object to remain at rest or in a uniform motion in a straight line is called inertia. The second law of motion, the law of force, mass, and acceleration. The acceleration of an object depends upon its mass and the magnitude of the force applied to it. When an unbalanced force acts upon an object, the motion of the object changes. The rate of this change over time is called acceleration. Acceleration depends upon 2 variables: the mass of the object and the magnitude of the applied force. In this example, a 3D character represents a pulling force on a 50 kilogram mass. Using his full strength, he has no trouble accelerating the object in the direction of his pulling force. If the mass is doubled and we want to accelerate it at the same rate, we must also double the force. Our character, however, is already pulling at his full strength. So what happens? He can only accelerate the object at half the rate as illustrated by his slower pace. This relationship between force, mass, and acceleration is the source of one of the most important equations in physics. Force equals mass times acceleration. The third law of motion, the law of action and reaction. For every action, there is an equal and opposite reaction. A direct example of the third law is the rocket engine. Look at the hot gases streaming out of the shuttle's engines. If this is the action, what is the equal and opposite reaction? It becomes clear as the shuttle is propelled into the sky. The reaction to the gases escaping from the engine is the pushing of the spacecraft in the opposite direction. Everywhere you look, these laws are being followed.